Hello students, this example is from section 3.2 of your notes packet. So the direction says find all values of x for which h of x equals to third root of 3x minus 6 and then plus 5 is differentiable. Is the function continuous? Okay, so differentiable, remember the question, the word differentiable meaning that, where is it that it has the slope? Okay, what part of the function? Again, continuous does not mean that it is differentiable. Okay, so that's not always true. Okay, so you have to find if it has a corner, a cusp, a vertical tangent, or discontinuity. Those are four locations that a function will not be differentiable. So let's talk about this third root of x. Yes, this is something that you do need to know. What does this look like? Okay, this is going to be something like this. Remember this in class? Okay, so then, but you are given this function. So third root of 3x minus 6 all under the root here and then plus 5 at the end. Well, based on your algebra skills, as you know, this is factorable. So it's going to be like this. Okay, so this is the translation now. If you can see this right here, by transformation, that negative 2 means you're going right by 2. Okay, and then the positive 5 meaning that you're going to go up by 5. So what's going on is the original parent function, the point of issue is really at 0, 0, but now you're no longer at 0, 0, right? You're going to the right by 5 and up by, right by 2 and up by 5. So the issue is really here. Okay, this is the issue. So issue at x equals to 2. Okay, now what kind of problem is that? Okay, what is the cause of this non-differentiable, or is it even? So this is where you're going to use your calculus. So on the left hand side, so left hand derivative at x equals to 2. Okay, so let's start with limit as h approaches 0 from the left of f of a, just kind of writing down the formula here, of f minus a all over h. So let's talk about x equals 2. What is f of 2? F of 2 is going to plug it in. Okay, so we are going to go third root 3 times 2 is 6. 6 minus 6 plus 5. So f of 2 is really 5. Okay, so f of 2 is really 5. Those are the parts right there. So let's continue. Since I know the location of x, limit as h approaches 0 from the left, f of 2 plus h minus f of 2. And again, I'm going to try to write everything down. So limits, it's more important that you try to understand it and then maybe write after. So listen to it first, especially if you are struggling in class, okay? Okay, so I will now plug in. Are you ready? Slowly. Oh, yep, that's my children. 3 times 2 plus h. Okay, close that quantity. Minus 6, extend this radical a little bit because all of that is still under the radical. Plus 5, so that's that first piece. And then minus f of 2, which is really minus 5, because that's what f of 2 is, all over h. Okay. As you can see, these two 5s are going to cancel. So now you are going to end up with limits as h approaches 0 from the left. I'm going to see if what's happening, okay? So slowly distribute, okay? Well, here we go. 3. That's going to be 6 minus 3h. Minus 6, this is all under the radical. So again, this is going to be, why did I write minus? I'm sorry, this is a plus, okay? And then those 6 are going to cancel. So what you do end up with is limits as h approaches 0 from the left, okay? Then I have third root of 3h divided by h, okay? That's all I have left. So what I'm going to try to do is break this down. Third root of 3, right? Third root of h, yes, that's totally legal to do, which is, oops, you know what I forgot? I forgot limits as h approaches 0 from the left, okay? Then this is going to be limits as h approaches 0 from the left. Now, as you can see, third root of 3, I'm going to keep it in the radical form. No big deal with that, okay? But third root of h, what I'm going to do is I'm going to write it as a fraction exponent in that way, like that. Then from here, well, think about it. These two are the same base. When you're dividing number with the same base, guess what you can do? Limits as h approaches 0 from the left. I'm going to keep third root of 3 here, no worries. Those two are from the same bases, so when you are subtracting, you can subtract the exponents. Would you agree with that? So it's going to be h minus 1/3. This has a power of 1, which is really 3 over 3, so that's what I'm going to do. Minus 3 over 3, which is really now limit as h approaches 0 from the left over third root of 3 of h times h to the negative 2/3 now. Okay, see that right there? Then I'm going to take this to the next line over here. So limit as h approaches 0 from the left. I'm going to attempt to write the positive h here, like that. Bring it to the bottom. So now limit as h approaches 0. Okay, and remember, I'm writing everything down so that way you have a better understanding. So now I can write, as you can see now what's happening to as h, oops, I don't need this step. Well, technically, you can do this if you want. Third root of h squared, like that. These two are the same, okay? So what's happening as h approaches, okay, what's happening as h approaches 0, right, from the left-hand side? So as h is approaching 0 from the left, okay, so let's think about this. So I need to pick something like negative 0.0001, would you agree? So negative 0.001 squared, that's going to be some positive number, small positive number, okay? So any number on the top doesn't really matter because I have a third root of 3 here, divided by a positive, okay, a positive small number, okay? That will give me infinity, okay? So this is giving me infinity. The reason this is not negative, even though we're coming from the left, is because this is a being square, that h is square, okay? Now, I'm going to do the right-hand derivative, right-hand derivative, okay? All the algebraic pieces are exactly the same. So all I'm going to do now is writing this last piece, h approaches 0 from the right. And I just have this piece, okay? The mathematics doesn't change, okay? So now, similarly, as h approaches 0 from the right, so I'm going to pick a value like positive 0.0001, okay, for h. And that's, I'm going to square that. It's still positive, right? But it's even smaller. So again, similarly, the top is third root of 3 divided by some small positive number. I'm going to end up with infinity again. And based on your definition, these are both coming out to be positive infinity, and both on definition, this is going to give you a vertical tangent, okay, at x equals to 2. What that means is that this is not differentiable, okay, at x equals to 2. So not differentiable at x equals to 2, okay? And the reason it is because it has a vertical tangent. Now, the second part of that is this function continuous? Yeah, it's totally continuous. Yes, continuous from negative infinity to infinity. So even though it's continuous the entire time, doesn't mean it has a slope at the entire time, okay? And this is the end of this recording.